Section 3 in Chapter 13 of the Klein 2nd edition textbook talks about the different ways that we can prepare alcohols. And this goes back to Chapter 7 and Chapter 8. I would make flashcards of each of these reactions and review them frequently. So first of all, we've learned about substitution reactions of primary alkyl halides. And if we treat this with sodium hydroxide, we can form a primary alcohol. The reaction mechanism here is SN2, okay? And it works by a direct displacement of the leaving group and we get the products directly, okay? So there's just two arrows that you need there for the reaction. The other way you can do a substitution reaction is maybe when you have tertiary alcohols, tertiary alkyl halides, I mean. So if we have, let's use bromine here. If we treat this with pure water, okay, we can get a tertiary alcohol. Okay, so I'm using those terms now because we've learned primary and tertiary, okay? So here you don't need acid or anything. If you buy a bottle of 1-bromo 1-methyl cyclohexane, you'll find that it says water sensitive on it. Now, how does that work? The first reaction that occurs here is that we have salicylisis, right? We generate a carbocation and a bromide ion floating around here. And then what we have is water, which is the solvent, comes in and attacks that carbocation to give you a protonated alcohol, okay? In the last step, to get the product, you need to deprotonate that oxonium ion using maybe bromide, maybe water if it's in large excess. I'll use bromide, okay, and that's an acid-base reaction. So let's label these steps as I like to do. In purple here for the SN2 reaction, we call that A for attack. In the salicylisis reaction of tertiary alkyl halides, we have in our first step elimination, in our second step attack, in our third step deprotonation. These are all customary ways to make alcohols from alkyl halides. Now, we can also make alcohols from alkenes, all right? Alkenes. And these occur by addition reactions, okay? If we have let's do cyclohexene. If we treat this with water, with a small amount of acid catalyst, say sulfuric acid, we can make cyclohexanol. And how does that reaction work? Let's do the mechanism here so we can all be aware of how that works. In the first step, we're going to have protonation occur between the alkene and our acid catalyst, okay? And we're going to form a carbocation. So I'll draw a little H there so we can see where it went. In the second step, we have water attacking the carbocation, okay? And that's a common theme that we saw last year when you took the first course in organic chemistry. And you form an oxonium ion. I'll leave the other hydrogen off there. It's just kind of weird to show it at this point. And that's A for attack, right? Water is attacking that carbocation. In the third step, what we have is a deprotonation. So I'm going to use water that's present here in the chemical reaction mixture, okay? And I'm going to draw that arrow pointing to this H, and then these bonding electrons pointing to the positive oxygen. And that's called deprotonation, okay? So in green here, we have an alkene reacting with water in acid catalyst to give you an alcohol, and the mechanism is PAD. Okay, PAD, if you want to use those abbreviations. Now, another way that we can do these reactions is with the alkoxymercuration demercuration procedure. It's a very complex series of reactions that proceeds through radicals and things like this, so we normally don't require students to memorize this, but you do need to memorize Markovnikov's rule, and you need to remember that this reaction avoids rearrangement. If you need a review of Markovnikov's rule, I urge you to look back on Chapter 8. We are going to get always the more substituted alcohol when we have a choice. So that's a great flashcard reaction there. No mechanism to memorize for this, okay? The third reaction that we have for addition reactions of alkenes is going to be the hydroboration procedure. Hydroboration, oxidation. Okay, and that's done with basic hydrogen peroxide. Okay, and again, the reaction mechanism is quite lengthy. There's a lot of interesting stuff going on, but we don't need to, in my class, memorize the curved arrow reaction mechanism. Okay, what we do need to memorize here are two features. It's anti-Markovnikov it occurs in a syn fashion, and there's no rearrangement. Review that in Chapter 8 if you need more information. So the OH goes over here at the terminal carbon, and you get the less substituted alcohol. So it depends on what you want to make. If you want to make a more substituted alcohol, use the mercury. If you want a less substituted alcohol, use the hydroboration. Okay? And that's section 3. It's a little bit of review.